So now that we know how to simplify and add and subtract and multiply and divide rational expressions, we can start solving rational equations. So I have one here that just has numbers in the denominator. So we're going to start with a simple example and then we'll move into something a little bit more complicated. So if I have something that looks like this, the first step I want to do is really to get rid of all of these denominators. So I'm going to start with that first one, which is a 3, and I'm just going to multiply both sides by 3 so that that denominator cancels out. When I multiply both sides by 3, I get this expression. I'm distributing that 3 to all of these different terms. Great. Okay, I still have 2 denominators left though. So now I'm going to move on to my second denominator. And for this one, to cancel out, I need to multiply by 2. So if I multiply by 2 on one side, I have to multiply by 2 on the other side. And I get this expression, or this equation. And then I still have one more denominator left, so I have to multiply by 2 in order to get that one to cancel out. So I am left with no denominators, which is great, because now I can just start moving x's around in order to isolate x and eventually solve for it. So I can simplify this further. From here, I'm going to add all the x's to this side, add all the numbers to this side, so I'll get x equal to 6, and that is my final answer. Now I could have done this a little bit more quickly by basically looking at my denominators and trying to get rid of them all in one fell swoop. So I did it in 3 different steps. First I got rid of the 3, then I got rid of the 2, then I got rid of the 4. But I could just look for a common multiple of 3, 2, and 4 and multiply by that from the very beginning. So 12 is a common multiple of 3, 2, and 4. So what if I took that beginning equation and instead multiplied by 12 on both sides? Then I can get rid of all of the denominators at once. Because when I distribute here, 12 and 3 simplify. 12 divided by 3 is 4. When I multiply 12 by a half, that's going to be 6. And then here, 12 and 4, again, is going to be 3, and that doesn't have a denominator. So then, once I get here, I'm just back at this part, and I can just solve for x again. So we can make things move a little faster by basically finding a common multiple of all the denominators and multiplying that multiple on both sides. Okay, so let's try and use the same methods, but for something with variables in the denominator. So here my denominator is x minus 1 and x. A common multiple of x minus 1 and x is going to be the product of x minus 1 and x. So x squared minus x. So if I multiply by that on both sides, I should be able to get rid of my denominator, both of them. So basically first I'm distributing here. So that's 12 times x minus 1 over x minus 1 minus x over x. And then this side stays the same. And then I can look, and my denominators are going to cancel out because I have x minus 1 on top. And then I have x on top and bottom. That cancels. So then this becomes 12x minus 8x minus 1 equals 2 times x minus 1. And then from here, I'm just going to start multiplying everything out and trying to isolate x and solve. Okay, so that's the same step. Here, I multiplied everything out. Here, I started trying to isolate everything onto one side, combining like terms, and I'm left with a quadratic. So now I have to solve the quadratic, either using quadratic formula, completing the square. Oops. I'm going to factor it. So I factor out the 2, and then I factor what's left over into x minus 4 and x plus 1. So my final answer is x equals 4, x equals negative 1. So summing up, what you do is you look at all of your different denominators, find a common factor of them and multiply it, and then multiply by that common